let's talk about what happened last time. Do you want to hold up the parts that broke last time?
Yeah.
And we had it on the last week's video.
Oh, jeez.
And just for everyone to see what it should look like, it should look like this. This is an exact replica print of that. It goes into the lower bicep or lower forearm piece. What's interesting is this is 3 walls, right? On this one,
Yeah, that one's printed with 3 perimeters.
and the infill.
And I think the infill on that one is 80%. 80% infill.
Okay, that's a lot. Yeah, you can tell this is a lot heavier than that. It feels a lot more dense. So, but this is like no joke. This is pretty thick too. But the 3 walls will definitely make it way stronger. So hopefully we don't get a break today. But oh yeah, we have more racks printed, just in case. The yellow ones seem fine, and the rack gears have like the least amount of work out of all the gears. So let's talk about the forearm pieces now. What's the difference between the forearm piece last time and this time?
Well, so one of the forearm pieces from last time in the graveyard over there split right in half on this section where this, like, the forearm kind of narrows in and they're significantly different looking. On that one, the difference was really drastic. And this is also pretty weak. Like, I could probably... I could, like, bend this like that. And this one is much stronger and held up pretty well. But we wanted something that would be able to hold the dumbbell well. So this is almost all 1 kilogram of the Amazon's Overture PLA Plus. And it's got 4 walls. It has 25% infill with triangles. This thing is dummy fucking thick. Like, it's... We've got these little supports on here, which I'm going to rip off. Yeah. I do not anticipate this having any of the issues that the other ones had. It could possibly have new issues just due to the sheer volume it is, but this thing is pretty good. Yeah, let's see how it holds one of the dumbbells. I think and this is something that we should establish, I think our target is 15 pounds, kind of arbitrarily.
That's the record, right?
Yeah, but we should have some key metrics.
So I could put up the math, but basically how it works is we have... How's that fit? Does that fit nice? Try and slide it around a bit.
That's not so bad.
Okay, that's great. So the theoretical limit for... Because there's going to be a mechanical loss with like maybe a little bit of leaks and the aluminum pistons, but because they're double acting pistons. So the theoretical limit was like 18 pounds or so. Like if you do the math at 150 psi. Not, maybe it wasn't 18, maybe it was like 22 or 23. Maybe I'll post it. So I don't think we should really push more than 20 pounds, but like as a does work record, we have 15 pounds without any breaks, like several curls at 15 pounds. I think it's like 4 or 5 curls. So we should try and break the record today and go for 20.
Well, should we?
A couple curls of 20 pounds.
Also, yeah, what are we trying to do here? Because
yeah, so today's
this,
a complete different day.
Yeah, this thing right here isn't really so fun to wear. So we're not really focusing on.
I want to say that's true. Imagine cutting off the top 2 inches of it. What would you say?
No. I mean, in like a larger scale. Like not like, yeah, sure, we can Velcro this to your arm, but like this is not designed to have the front piece clamp onto your arm. And it is
a little bit. Oh, but no, this is purely a test piece.
Yeah, no, exactly. That's what I'm saying.
That coincidentally does fit an arm.
That's exactly what I'm saying. So if this is a test piece that just coincidentally is, physically actually does fit into my arm in its cavity, I think we should still focus on some metrics that we're actually trying to aim for and go for. So like maybe right now we're just doing like 15 pounds, you're saying 20, but maybe we should have some amount of weight with some amount of curls.
So for this one, we have multiple ratings we want to do. We want to do better than last time because we changed the design. And we probably want to achieve equivalent, if not better, percent of like what's theoretically possible.
Yeah, but I'm thinking because we do this like with weekly sprints basically. We should have like these metrics that we're aiming for, and we
Yeah, we should write them on the board.
Yeah, we should write them on the
Yeah.
board, and we should like check box if we did meet it, and if we haven't meet it, then we should meet it the next week.
I understand. Let's talk about the future. This is a lower bicep piece. We have Amazon was selling this on deal. It's a tie rod for our
Okay.
car. So this is cool because this is the lower bicep, and this is 5 millimeters taller than the other one, and it's cool because it's black and it looks fresh and shiny.
That's also 4 perimeters
Yeah.
of one
So
printed. The other one
this-
was 2 perimeter.
I'm actually sitting at a great camera angle right now because this 5 millimeter.
There you
So
go.
this 5 millimeters that we've added is extremely relevant, and you can kind of see it pretty well because the camera angle. This rod that I'm tapping into my back is actually exactly where I want it to be, which is really interesting because we'll mount it to these shoulder pads. We'll mount it to these football shoulder pads, basically where you saw me touching my back. And we'll have to print something to hold it, but it's basically going to go on right here. And this is a very similar configuration we just saw. Maybe at the end of today we'll put it on and we'll measure it out. But this might be like a very successful design to putting the power arm breaker version 0.5 on Marker myself. So I've already broken my arm multiple times, so it's not too bad. Mark hasn't yet, so I think you would probably need to volunteer.
I broke
to
my
test
wrist
it.
though.
Yeah. So we'll I don't know, is there anything else to talk about? We have the
Yeah,
next
maybe I
version
can
of the
write some of the
bicep.
stuff on the board.
Yeah, go for it. Okay. Yeah, maybe write more requirements lower on it.
Yeah,
So we want to build a so we want to build a wearable like the football version. So for we're on 0.4 right now on testing. I'm going to consider this 0.5. We want to build something that's wearable. That's not necessarily like mechanically operational or safe. Well, it doesn't matter about safe or mechanically operational. It's just going to be all the parts on your arm with no pistons and no air power. And it needs to wear nice and feel good.
Yeah, wearable.
So let's just call it wearable. And then after we have something that's wearable, we can start making it more comfortable, and that'll come after we have because we don't have anything to wear right now.
Let's start assembling.
Yeah, we'll do some assembling and then we'll do some testing. So we have 5 pounds on the arm. We drilled the holes bad in the arms, so or like in the supports for the forearms. Maybe Mark can point at them, but it doesn't really matter. So I'm just gonna practice. Yeah, put your safety goggles on, everyone. I'm gonna practice curling. This should be really fun. Oh my god. Okay. Oh my god. Okay. I need to apply the brakes all the way. Okay. Hopefully I got the brakes right. Gotta test it. Alright.
Yeah, the bicep broke right there.
And now gotta test it. Alright.
Yeah, the bicep broke right there.
And now all the weight is on the pistons, bending the pistons. Just gonna do some tests. I think I got the brakes calibrated right. moving up to 10 pounds now. Let's see what happens. I guess I should say, what's interesting about this 15 pounds is that it's out 13 inches, which is a few inches more than what we traditionally been curling at. But 13 inches was from the center of my elbow to the center of my palm. So this is the biggest strain test that we've done so far. We're getting a lot of bending. I'm using the little air compressor. I'm thinking about turning this off and setting up the big air compressor, because the small one I don't think goes over 90 psi, and my larger one will at least get up to like 115 psi. Cool, so once that compressor kicks off, then I'm gonna go ahead and go for the test, because we'll be at the max psi. Just some 5-pound curling fun for a little bit to test things out. But like we mentioned on the 15 pounds, our major weak points are the rack gears and the top of the piston coupling, or the top of the piston rainbow coupling. Now the reason why you'll see this 10-pound weight make some acceleration as we get to the top is because we're using air, and any gas is very easily compressible, which means as there's more tension in the pistons, it's going to build up density of the air pressure because it'll compress, and that's why you'll get the acceleration as we get to the top, because it's becoming more and more and more dense. And then once the load lessens, after it makes the apogee of the 90 degrees, because it comes in a little bit, like how I can bring my arm in beyond the 90 degrees mark. This part is where you see the acceleration at the top, where this guy comes here. So we're just going to play around with it though. 10 pounds is a lot of weight, so we'll see what happens. Lots of bending going on the rack, but it's holding the 10 pounds. That's the same thing for on the way down too. Why it comes down so hard is because it's letting out all the high pressure air first, just to push the weight over the 90 degree apogee here. There's the true 90 degrees, and then it just swings down, because then it repressurizes, and that's the catch. if we move to fluid, which we plan to move to fluid, maybe like water or antifreeze or a combination of both, or maybe even some type of like power steering fluid of some kind, I don't know yet. We won't get this compression issue. So we'll have like a consistent amount of power all the way up and all the way down, rather than this like bouncy, springy feel that we get from the compressing air. No, but this is handling 10 pounds amazing. That's a lot of weight to have on here. This is about 2 pounds of plastic. This is a lot of control. You can tell. I mean, you can see this whole table moving. So I'm just going to be a little reckless, and I'm going to put 20 pounds on there, and I'm going to see what breaks. Okay, it's go time.